All right. So, whenever we have redundant path, whenever you have multiple paths, redundant paths between two eBGP neighbor. See, in our topology, we have only single path between these two router. I have only single wire. What if I have another wire? If you have another wire, you will have another address. For example, if this is 11.0.0.1, 11.0.0.2, and this is 17.0.0.1, 17.0.0.2, now will you form neighbor using two address from R1? Will you say two neighbor address 17.0.0.2 and 11.0.0.2? No. Not like that. We need only one address. So we will use this address, loopback to loopback. We'll form neighbor using loopback address to loopback instead of physical address. If you have a redundant path, then you will have redundant neighbor. You need to create two neighbors, two sessions, two BGP sessions, which will increase the CPU. Not only that, it is not necessary to have two separate sessions for one eBGP neighbor. And not only that, when an update needs to be sent, it needs to send two copies, one to this address, another to this address. Okay, so what is the solution? Solution is we use loopback to loopback. Fine. If you're going to form neighbor using loopback addresses of these two router, what are the things that we need to consider? Number one, TCP protocol. BGP is a TCP protocol. It needs to have a reachability to this neighbor address. Only then it can try doing three-way handshake. So first thing is we have to provide route. R1 should know to reach 2.2.2.2. R2 should know to reach 1.1.1.1. So the first thing is we will write static route. We will write static route on these two routers so that this loopback address can be reached. Number two, static route alone is not enough. When you form neighbor, you need to source it with loop back address. Update source command that we need to do. Third thing, because it is an eBGP, by default eBGP neighbor need to be connected directly. To override that, we need to break that rule. To override that, we have to increase the TTL value, which is by default 1. By default, outgoing TTL is 1 for all the BGP packets. Now, we need to increase the TTL value to tell the router indirectly that the neighbor need not to be a directly connected. See, 2.2.2.2 is not a directly connected route address to router 1. 2.2.2.2, which is on router 2's loopback, is not a direct network. So, when we say outgoing TTL2, what happens is you're breaking that default rule saying eBGP neighbors need to be directly connected. Alright, so these are the things we are going to do to form neighbor. For that, what is the command to do this? We say neighbor 2.2.2.2 eBGP multi-hop 2. This is the command that will inform BGP that you can form neighbor even if it is not connected directly. Is that understood? So now we are going to paste the configuration for router 1. You see? Fine. If you see here, we have assigned this loopback, we have assigned this fast Ethernet, we have given a route to reach the neighbor, which is going to be 2.2.2.2, the router ID of router 2, the loopback interface address of router 2. We are forming neighbor using loopback interface. So before we enable BGP, we have given static route. It's not mandatory, it should be done before. Even after that, you need to make sure it is pingable, that's all. So we have a neighbor, remote ASS 20. We also said neighbor update source loopback 0. That's the next line. And then neighbor eBGP multi-hop 2, so that the neighbor need not to be directly connected. Directly connected network is only 11.0.0.0. 2.2.2.2 is not directly connected. That's why we said eBGP multi-hop 2, so that outgoing TTL will be 2. Fine. Now we have configured R1. Show IP BGP summary. I should see neighbor configured. But router 2 is not ready. That is why it is active. It is totally not ready at all. That is why it is not even showing idle. It is saying active. Meaning there is no one called 2.2.2.2. There is no one called 2.2.2.2. That's why it is active. There is no one called 11.0.0.2. See, I gave static route to send the packet to 11.0.0.2, but we don't have 11.0.0.2. See, there is no 11.0.0.2. Yeah, question.
Sir, yes, sir. Sir, by default, the eBGP TTL value is 1,
Correct.
right, sir?
Correct.
So why we are not configuring 1, sir, apart from 2?
See, we are trying to form neighbor between two loopback interface, correct?
Correct.
Are they directly connected?
No.
By default it is TTL1, which is also indirectly telling that eBGP need to be directly connected. When you say 2, you are informing router that the neighbor is not directly connected.
Okay. So which means that we have 2 networks, that is 1 and 2, correct, sir? We have a 2 network, that's what we are giving 2, sir?
No, not like that.
Okay.
We are saying the neighbor can be more than 1 hop away, behind 1 hop.
Okay.
The neighbor need not to be directly connected. He can be behind more than 1 hop away. We are breaking that rule by saying eBGP multi-hop 2. Alright, now for router 2, let's do the configuration. It is 2.2.2.2 loopback, and on the physical interface it's 2 here, and then this is 1.1.1.1. To reach 1.1.1.1, it should be sent to 11.0.0.1, which is router 1's address. That's the static route, and BGP is 20, and the neighbor is 1.1.1.1.
The
neighbor on that remote is
10. Now let us paste this on router 2. Now you will see soon after I finish configuring, you will see neighbor coming up. See, neighbor has come up already. Now let us go back to router 1 and check. Show IPBGP summary. It's no more active. It says the neighbor is up for last 10 seconds. But so far no advertisement from router 2. That's why it is 0. We saw the network command in the early classes.
Correct.
If I would have advertised a network, I would have got some number there. Let me do a small advertisement here. Interface loopback 22, IP address 22, 22, 22, 22, 255, 255, 255, 255, and I'll say router BGP 20, network 22, 22, 22, 22, mask 255, 255, 255, 255. Now let's go to router 1 and check the same output. I should see 1. Yeah, I am seeing 1. What does that mean? 1 network learned. Which network, if you want to know, then you simply type show IPBGP. This is the network. This is the network coming from the neighbor 2.2.2.2. See, the next stop is not 11.0.0.2. The next stop is the address of the neighbor. How do you identify router 2? Not with 11.0.0.2. We said neighbor as 2.2. That's why it shows 2.2.2.2. And it is coming from the autonomous system number 20. Right now, if you try pinging 22.22.22.22, it will ping because in routing table you have the route to reach 22.22.22. All right. Any question?
So for currently the R2 router ID should be 2222, does it?
No. See, router ID is same like OSPF. When you enable BGP, what loopback you have, it will check. If you have multiple loopbacks, it will pick the biggest IP address of the loopback interface. But when I enable BGP, there was no 22 network. There was only 222 network. So the router ID, if you check, go to router 1 and check, show IPBGP neighbor. It will show the neighbor's router ID as 2222, not 222222. See, the router ID of neighbor is 2222. Maybe in your next reboot, no, when you restart, the router ID will change to 22. You got it? You can also check that in router 2 itself, show IP protocol. You can see here, show IP BGP. Yeah, here the router ID, local router ID is
22.
not 22. 2.2 router ID.
Yeah, 2.2 does.
All right, so that is what a question from Anbu. How to use this multi-hop eBGP multi-hop command. Now I want to show you something, and then we will get into other topic. If you go down here, because I changed the TTL value to 2, you can see here outgoing TTL is 2. That's what I wrote and told you here. By telling eBGP multi-hop 2, we are changing the outgoing TTL value. So while sending the traffic out, the outgoing TTL value is going to be 2. Now, if you want to do some changes to inbound TTL, then command is different. The command will be this command, TTL security hop. eBGP multi-hop is focusing on outgoing TTL. TTL security will focus on incoming TTL. See what happens when I put that command. I'm going to remove this command. I'm going to remove this on both the router. remove this, and now I'm going to clear BGP. Do clear IPBGP star. Now that's all. The neighbor won't come up because the TTL is not there in both the routers. See, the neighbor has gone down. Now I'm going to say neighbor 1.1.1.1 TTL security hop 2. Instead of saying eBGP multi hop 2, I'm saying TTL security hop 2. And I want to show you the difference between these two. Neighbor 22222 TTL security hop 2. As soon as I hit enter, you will see neighbor coming up again. You see neighbor will come up now. Yeah, neighbor has come up. Now I want to show you the difference. Show BGP neighbor. This time outgoing TTL is 255, but the incoming is 255 minus 2. Why 255 minus 2? Because I said TTL security 2. TTL security 2 will impact only the incoming TTL. We are saying my neighbor should not be more than 2 hop away. Understand this. My neighbor should not be more than 2 hop away. If he is more than 2 hop away, the TTL will be 252 or 251. See, if neighbor is, let's say, coming from here, 255, when it goes from here 254, when it goes from here it is 253. For every hop TTL will get decremented. Right. Now, when it comes here, then it is becoming 252. He won't agree. He says minimum 253, meaning I'll accept 254 or 253. I will not accept 252. That is the meaning of it. So this is more secure. This is to clearly say my neighbor should not be more than 2 hop. Right? This is more secure.